This is part 4 of a refactoring series. If you need context, you should go back to part 1. In this part, I'm going to take some of the functionality that connects to something I couldn't control in a test and move it out into its own custom hook. And that will serve as a stepping stone that we can then use to inject that functionality by tests in a later video. The specific kind of touch point that I want to work with is this wakeLock concept, keeping the screen from locking over time. And there's 4 places where we reference it. We have 2 hooks that we call, 2 hooks that we call, one to create this state that we never actually manipulate, and then one to create this ref object that we do. So I'm going to take these and I'm going to move them to the top of this method. And it doesn't really need to all be moved to the top. It all needs to be moved together so that I can extract it. But the top is as good a place as any. The other points we have are these 2 methods where we release the wakeLock and acquire the wakeLock. So I'll take those and I will move them to the top as well. So now I have this nice little kind of block of code that I want to extract. It's not going to let me extract it quite yet, but one step at a time. So I'd like to be able to just introduce a constant. That's not something it does for me. So I will do it by hand. That's transformative. That doesn't change the behavior at all. So I'll do it again. Now I've got constants that I can use throughout, and that I do use throughout the rest of this this method, this function. You can see here's a call to it. Why this is valuable is because that allows me to extract a method, and I will call it useWakeLock. Okay, let's see. So when I look at the useWakeLock method, I can see that it's kind of what I want. I'll have to do some more refactoring later, but one thing I need to do is create a type for this wakeLock that I want to be able to inject. So I'll infer the type, that's automated, and then I'll extract an interface, and we'll call it wakeLock. Okay. Now, if I go back to useWakeLock, I can see that I can create a new constant for its result. We'll call it wakeLock. Oops, I put it in the wrong place. Try again. Extract it into the closing scope. wakeLock. All right. So now I've got a place where I have an object. That's the object I want to be able to ultimately substitute for test purposes. And I have it's destructured into local constants. So again, one step at a time, change this to let. That's not going to change the behavior of the system at all because I haven't changed any other places where it's used. And then I'm going to create an assignment. This assignment, the identity assignment, is not going to change the behavior. But then I can make it wakeLock dot release wakeLock. And that's still not going to change behavior because this was originally just destructured from here. Okay, I can now repeat that process. I will say acquire wakeLock equals acquire wakeLock, and then I will simply prefix it with the object I want. Why that's valuable is that I am now able to make these into their own constants and inline them. And this basically transfers all of the coupling that was by way of these local constants, local variables that the compiler is not going to let you change really, or the interpreter maybe. It's going to transfer that to be calls to methods on a type, on an object, which is defined in this interface. So a few more things to clean up. When we have wakeLock, we just want to say like release instead of release wakeLock. That's a little redundant. We want to say require, and then this kind of looks a little bit ugly. So we'll just inline these variables. That way we don't have to deal with like double renaming. That doesn't work very well because it doesn't tab things in the way it really should. But again, that's easy to transform. The other thing I notice is this state is never, ever, ever changed. useWakeLock was never set. So this useWakeLock should always be true. And that means that wherever it's used, I can simply replace it with true. And it's only used in one place. So I can replace that with not true with false. That doesn't change anything. Then I can get rid of this unreachable code. And then I can also get rid of this. So now I have a nice, clean definition of useWakeLock. And then in a subsequent video, I will be able to take that and transform it so that I can substitute this behavior for the purpose of tests. I hope you enjoyed this video. Thank you.